So containers, managing containers and managing Kubernetes, it's a challenge. It's not easy. So my goal here today is to show you how we at AWS, we can take some of that heavy lifting off you and to make your lives easier. My name is Kevin Nash. I'm actually a senior solution architect, not a customer engineer. But we kind of do a lot of the same thing. I'm a member of the container field community. So this is the reason for the invite. So thanks to Tobias and Marco and Michael for inviting me here. This picture is from back in the day, but I also, when I get a chance, I like to climb outside to Boulder. The agenda for today is that we're going to talk a bit about EKS auto mode. Actually, who has heard about EKS auto mode here? So that's about half. And who works on EKS regularly? About half as well. Okay, so that's good. So I have a few slides about the basic concepts of EKS. And then I'm going to do a demo. Now this demo is not recorded, so hopefully the demo gods are with us today. Great. While preparing for the demo, what I want to do first is prepare some infrastructure. I'm going to set that up. 1 second here now. Just escape on the. So I'm going to prepare some infrastructure first, and we're going to return to this at the end of the session. So here we have a screen with 3 panes. On the left-hand side, we have K9S, which is my favorite tool for integrating with Kubernetes clusters. On the right-hand side, we have a service, and the service is exposing a pod, a Monte Carlo mathematical calculation. The details of it are not so interesting, just show you that it's a mathematically intensive application. And then down below we have the CPUs. So CPUs, here we can see the control plane and the data plane nodes. So what I'm going to do now is create this service. So I'm just going to. So my question to you is, what would you expect to see on EKS, regular EKS, once you create the service?
There will be a load balancer equation in front of the cluster.
There will be a load balancer if you install the AWS load balancer controller.
Yes.
So this is one of the differences between EKS and EKS auto mode. And I do a fair bit of demos, and in order to install the load balancer, you have to install the load balancer controller, then you have to create an IAM role, map that role to your service accounts. So there's a lot of heavy lifting that you have to do beforehand. And with EKS auto mode, we've taken away or taken that automation off your hands. So you can create your service and then automatically create a load balancer behind it. So let's just do a refresh here. And we can see we have a load balancer provisioning behind the scenes. So this is preparation for our demo. Let's leave that in the background and go back to our presentation. So just want to recap on some of the, at least for me, some of the important things of a Kubernetes cluster. The first thing is that we have a control plane and a data plane. So the workload runs on the data plane, and then we have a control plane which manages that. Now, what we don't want is that if your control plane goes down, that your data plane goes also down. An example of this is if you're watching TV and your remote control goes out of batteries, you don't want the television to stop working. So this is a separation of control and data plane. Typically, we install these planes in different availability zones or different geolocated data centers. So, for example, you could run part of your control plane on a factory floor, on premise. You could run the control plane in AWS and multiple availability zones. What you don't really want to have is your control plane running in Sao Paulo and your data plane running in Ireland because you have too much latency. And then on the flip side, you don't want to run everything, both control and data plane, on the same node, because if that node crashes, then you have scalability and reliability problems. You can run EKS anywhere. So you can run it, we have customers run EKS on cruise ships, running through the Antarctic. We have customers running Kubernetes on-premise on the factory floor. You can even run Kubernetes on a Raspberry Pi with K3SD. And of course, you can run Kubernetes on AWS. So the point here is you can run Kubernetes anywhere you like. Another important point is that you can distribute your data plane. So you can run part of your data plane in the cloud, and you can run part of your data plane on the factory floor. And we call this a hybrid deployment. So the word hybrid can be used for multiple different things. In the EKS sense, we mean hybrid deployment of the data plane. And finally, here we have like a tree of how we inherit from the EKS, the Kubernetes open source project. So what we do is we create a distribution of Kubernetes called EKS distro. And that's taken from the upstream. It takes the upstream project, Kubernetes project, wraps it in capabilities to integrate with AWS. So for example, you would hear IAM functionality integrated. And then this distro is used as the basis for our EKS suite. So EKS Anywhere, EKS Hybrid, and EKS Automote. The point here is that if you have applications which run on, say, version 1.3.0 upstream, they will run on 1.3.0 in EKS. So we're upstream compatible and certified. So EKS was created 7 years ago, and the reason that was created is because customers were giving us feedback that actually it's quite difficult to manage the control plane. To manage, monitor, and scale that control plane takes a lot of effort. So this is the reason why we created EKS, and that took a lot of heavy lifting away from customers so they can concentrate on what they did on a day-to-day business. Since then, EKS has become the most trusted way to run Kubernetes on AWS. So we have tens of millions of customers, clusters running each year on AWS. And as I mentioned, it's fully upstream certified and conformant. So diving a little deeper into the EKS architecture, what we see here is that the data plane is distributed across multiple availability zones. So these are multiple distinct regions. We have multiple instances of the API server and also multiple instances of the key value store. And the reason we do this is because we want your control plane to survive a single AZ event. So if a single AZ goes offline, and this is like extremely unlikely, but if it does, your Kubernetes control plane will continue to run. We also have questions from customers. Well, okay, does this control plane scale? And I heard Philip was talking about customers with thousands of nodes. So if you run a data plane with like 3 or 4 nodes, or you run a data plane with thousands of nodes, it puts a different load onto your managed control plane. And we scale the managed control plane to deal with that. So we take some signals such as API metrics, cluster size, and the size of the key value store, the etcd, to scale the control plane. And that will stay scaled for a number of days until we see that the usage drops on your application plane. So that's EKS as it was before re:Invent 2024. But we listen to customers. We take feedback from me, and if we hear customers come to us and say, well, listen, we really need help with this area, or we would really like to see the feature, we put that into our backlog, and particularly if a lot of customers are asking for it, we prioritize it. So customers were saying, well, it's great that you have a managed control plane, but to run an application, we need to invest more effort. So this is the reason why we created EKS Automote, to take that heavy lifting of you. And it's quite an evolution in the in the EKS service, and it's also our vision of how Kubernetes should run in the cloud. So what is EKS Automate? First of all, it includes some core capabilities. And these core capabilities are the likes of service discovery, load balancers, control plane, nodes automatically creating those. These are packaged into EKS Automate. So in the initial example here, when I created a service and automatically had a load balancer created associated with that, that's an example of EKS Automate automating part of your work, which you will have to do otherwise. We automatically provision infrastructure. And so underneath the hood, we use Carpenter. So who here uses Carpenter? So a few people as well. So this is a project which we worked on and open sourced. What it does is it manages the data plane. So we look at the description of your pod, we match it to a Carpenter node pool, and we say, okay, this pod can run on a particular EC2 data plane node. And what we do is we continuously look at the load on your data plane. So if our metric server is monitoring your application, we see the load go up, we will scale out the data plane. And also we will scale it in. So you can imagine if you have an event during the night, and let's take São Paulo again, you have an increased load, that load stays on for 30 minutes. We will scale in after that load has reduced. Wait 1 second. Okay. I hope you can still hear me over the air conditioning that suddenly decided to go on. And it's on full blast. So if we look a little deeper, no, you can't. Nope. That's better. I don't know what happened there, but the building decided it was going to kick into action. So this is, so this is the EKS architecture prior to, prior to the launch of EKS Automate. And what we see on the left-hand side is the managed control plane in the pink box up here. So let me highlight that. So here we manage the managed control plane across multiple AZs, and we expose that to you via an API. But on the right-hand side, we can see all the stuff that you had to add. So you had to add load balancer controllers, Carpenter, for example, if that was you needed for your application. You also had to manage the EC2 instances and the associated AWS services. This is the world with EKS Automate. You can see that on the left-hand side, that pink square is expanded. So we've taken those managed capabilities under our hood, and thank you very much, and automated them for you. So what does that look like in reality? Well, here we have an EC2 managed instance that is running on an AMI. And on that AMI, we run these managed services such as VPC CNI, Carpenter, load balancers. These run as processes. So when you go into your Kubernetes cluster, you would typically be expecting to see these controllers, but these run on these processes on the AMI. And the reason we do that is we can manage them on your behalf. So we talked about managed capabilities, but what we also offer is automation of day two operations. So take the example of EKS Automode Kubernetes versions upgrades. So my question to you is, you're upgrading from 1.3.0 to 1.3.1. What do you do?
First one version up.
Yeah, exactly.
Jump versions.
Yeah. So what do you typically do?
Just do multiple upgrades.
I would do one single upgrade at a time, but the first thing that I would do is make sure in my test integration environment that your applications are green. That would be the first thing to do, because I mean we can give upgrade insights into what compatibilities your controllers running on EKS have with future versions, but we can't say how will your application deal with that.
Yeah.
So make sure that your application is green, and then you can kick off the update process. And once we start from there, we automatically automate the rest of that. So we'll update the control plane, and we also update the data plane nodes. But it's up to you to kick off that process. So that's Kubernetes version itself. What we also have is the data plane nodes. So here you can imagine, let's say that we need to upgrade the DNS service. It might be for like a security patch. We will do that automatically for you. So you note here that the Kubernetes version stays the same, but we have an AMI here, 1321. We have a new AMI, 1333. We will automatically update the data plane nodes on your behalf. And we do that regularly. And we also set some limits on that. So by default, we restart nodes every 14 days. That can be extended to 21 days, which leads me to think that the EKS Automode team were blackjack players. Important point here to note is that you can control that. So you can set node disruption budgets and pod disruption budgets. So you can say, okay, listen, we want only 10%, for example, of our data plane nodes to be upgraded at a particular time. But we will, if nothing else happens, within 21 days, restart those nodes and upgrade them. And this is in line with security best practices. And we also publish more best practices. So these are here for you to browse at your leisure. We also take pull requests on this documentation repo, so they're also welcome. So now we kind of have a bit of the theory in the background. Let's look at our demo. So you remember that we set up a service that should be hopefully deployed now. And what is running on that demo is a Monte Carlo integration, which can be used to calculate the number of pi. So what has happened is that you have a square and a circle. You take points at random, and if the points are inside the circle, then you can use that to calculate the version of pi. So you're going to exit out of this and go to our demo mode. So first of all, we can go to our console. You can see here that we have load balancer, which is now active. And if we look into the resource map, we have a listener and we have one target group and one target. So this is the one example of automation. What I would like to show you is how the data plan scales under load. So we're going to load test this application. So let's first of all do this is an environmental substitution of our, actually we want to do an echo of export the URL. So this is using the kubectl CLI to take the URL of the service that's been exposed to the internet. So you can see it here. Now we can send in a recur request to it. This is going to ask for a calculation of pi based on one iteration. And remember, this randomly chooses the coordinates of that value, xy value. It has calculated the version of, or the value of pi to be 4, which is, okay, listen, we know pi is not 4, we could do a little bit better than that. So let's increase the number of iterations. 50, okay, 3.04. And if we increase to 1,000 here, we can see we're getting closer to the 3.14 and whatever, and change. So now I think we're ready for load testing this. So a reminder here, what we see down below, so this is the bottom section of the screen, is 2 nodes. One is the data plane node, another is where we have a system critical infrastructure running on. And the data plane node is defined by a node pool, which we can look at here. So this is a node pool definition in Carpenter. I've asked, okay, I would like to run some spot and on-demand workloads. I don't want to run certain types of infrastructure, and I want to have a capacity of 1 terabyte on the node pool, which I think is more than enough. So you can define this as you will. So let's start the load test. And so what we should see here, I need to do a substitute. So this is our, I'm using drill, and that is using a template, and here I substitute in the right URL for the template. I'm going to try that again. Okay. So now we set up 5 threads to hit the Monte Carlo calculation 4,500 times. And it's replying in between a half a second and 3 seconds. So let's look at we can see here down below we've already some activity. Let's go over onto the itself and look at the horizontal pod autoscaler. Up here I've set the target of 20%, so it starts to scale out once the CPU usage on the pod has 20%. This is very aggressive and it's underutilizing the pod, but it shows us for a demo how we can scale out. You can see the auto mode is automating the scaling out of the data plane. So we started up a new node and we started to deploy pods onto that. So if you look at the here we can look at the pods. We can see we started off with 1 pod. If you remember in our load balancer, we had only 1 target here, 1 pod, and now we've 5. And this will continue to scale out as long as our load continues to hit the load balancer. So this is an example of how automotive starts to scale out on demand. And then how does it look like in the how does the EKS automotive look like in the GUI? So let's look at the console here. So here is our clusters, container on AWS. We have a compute node. We have 2 node pods here. And if we go into one of those, you can see we've 56 pods running on that. We can have more insights into what's going on in the cluster by looking at CloudWatch. So for example, here we have container insights. We look at our cluster and our namespace here. And here is an example. Let's do the pod utilization. So here in Monte Carlo. we have, maximum CPU utilization of 25%, which corresponds to the autoscaler, we set a target of 20%, so it's trying to keep the CPU to 20%. Very good. So that is the demo. That is EKS automating your lives. Is there any particular questions that you would have for me? Why you switch?
Why your spots are free?
Pods are free.
The price isn't updated, like, is that, like the monthly price?
Have a special subscription.
So okay, so 0. That is a that is a good question. I don't know, but that's very good. That is a very good price. I mean, the price of spot instances go vary according to demand. So maybe there is zero demand for these nodes. And it's a good example of in your node pool. If we go back to our definition of the node pool, we have said, okay, not only use spot on demand, but use spot. So you have the flexibility to run on the cheapest infrastructure. And Carpenter is going to choose what the optimal set of nodes to reduce your cost to the absolute maximum. I think that is it. There's another question.
With the EKS auto mode, do you still have the flexibility to choose the CNI, for example, like one?
VPC CNI.
Sorry?
For how you manage the networking, is that your question? So So the load balancers, basically anything that you can deploy on Kubernetes, you can in principle deploy on EKS auto mode, but we support the VPC CNI. So for example, if you want to use Cilium, you would install a separate managed node group in addition to that. So you got to look at your requirements. Does your requirements need the richness and power of Cilium? Then you can install that in a separate managed node pool. But by default, we try to put all our networking support into the VPC CNI.
Plans to extend the tooling, so like metric server or Lattice?
Yeah, so we're taking just the same way we decided to create EKS auto mode, we're taking feedback from customers. So if customers are coming to us and saying, okay, well, listen, we would really like a particular managed service, and we will consider that for inclusion on the roadmap. So do you have anyone in particular in mind?
Just like metric server.
So metric server is already
there.
yeah.
Okay, but then there's like the gateway API.
Okay. Yeah. So
I mean, the more things managed in EKS, the better.
exactly, and this list is going to grow. Like we took, for example, Carpenter was very popular, so we took that first, but we're going to grow that list for sure.
So there are actually three ways how you can install these add-ons, these software solutions onto the Kubernetes cluster. So you can do it yourself. What you have done in the past, there are add-ons that you can use. So and more add-ons from the open source community are added to the community add-ons. So for example, metric server is one of those, or SQL is one of those. So with that, it makes it really easy to just be careful and add it to metric server as a community add-on, and it's fully managed by AWS, fully upgraded, and you have the same experience as you had in the past, like with CoreDNS and stuff like that. And then there is the Automode installed add-ons, and that's right now, as Kevin said, is ALB controller, EBS, PSI driver, the VPC CNI,
Carpenter.
Pod
Carpenter and pod identity, exactly.
Carpenter.
Yeah.
What happens if you use EKS auto mode, they're actually not visible. When you do the keep cutting at pods, you don't see those. So they're actually hidden because they run on the node itself, or actually on the control plane itself. So it's more like system processes as they run.
Exactly.
So, and that's also why it is not so easy to bring stuff where you need visibility on the pods, on the Kubernetes CLI and visibility. Because you need to expose it on another level. So for example, Carpenter, in the past you could look at the Carpenter logs and see what's happening. You can't do that anymore because it's not fully abstracted away in the control plane. So what you do is you expose that information now in QCOP described on the nodes itself, for example, as events and metadata information. So there's a lot of heavy lifting that AWS needs to do to bring these solutions onto the control plane. But more and more stuff, as I said before, is now as community add-ons available. That takes away a bit of heavy lifting from your shoulders.
But I think the community ones are quite old.
Yes.
Maintained really.
Yes. Yeah. Feel always free to do it yourself. So if you need a new version, then do it yourself. Yeah. You can always do that. So you can make. So if you go into a mixed mode of Carpenter auto mode, and you want to run something CNI yourself, you just install it on top. You just need to see how much compatibility. Okay. Was that correct, Kevin?
Yep, very good. You did. You had one last. Do we have time for one last question, or are we going to next?
One last question.
Yeah.
With load balancer, do we still have those options of like target group binding?
Yeah.
So
Yeah.
it's fully transparent. in this
Yeah.
case.
Okay. Listen, thanks very much for your time. Yeah, it was a pleasure speaking to you, and yeah, all the best.